Hello everybody, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. In this video today, it's going to look at your homework problem when it comes to setting up a 2D Cartesian coordinate class. And we're talking like Chapter 13 and Chapter 14. Chapter 13 handles the beginnings, the basics, the foundations of data hiding encapsulation. Chapter 14 covers operator overloading, the static keyword, and a few other odds and ends, of course. And then what's not covered in this video here is Chapter 15 stuff, which is inheritance, polymorphism, virtual functions, those kind of cool things. So here is our problem. I just have a very basic skeleton outline for my main function, but I haven't set up any of the class stuff just yet. So we're gonna start right now. So all I have right now is just a source.cpp with just enough to get a blank, empty program running. Okay, so you see I have my main function is in a file, and so the rule of thumb that we're gonna see here is that for every class we create, we're gonna create two separate files. We're gonna create the .h file, which is the header, which contains header information, obviously. And then we're going to contain and create a CPP file, which basically implements all of the functions found in the header. So the rule of thumb is, at least as it is right now, is as we're going through and writing this program out, we're going to have a total of 2x plus 1 files. And the x is number of classes that we're creating. And so since we're creating one class, it's 2 times 1, 2 plus 1. So we're going to have 3 files. So this is the one, and then we're going to have the 2 others. So I'm going to right-click here, add a new item, and I'm just to keep it easy, I'm just going to call it Cartesian. And I just have to spell Cartesian. I'll just say Cartesian coordinate. Why not? Go nuts, Brad. But and 2D. Why not? I'll just whatever. I'm just all over it today. So Cartesian coordinate 2D. .cpp, I'm sorry, .h, I add that in, and there is my file, and there's nothing in here. So I'm going to set up my class, Cartesian. Cartesian coordinate 2D. Okay, so there we go. Don't forget the semicolon there. For some reason you need it. Who the heck knows why, it's just the way it is. So I'm going to start setting up my public area and my private area. So again, since this is kind of maybe newish to a lot of people, the public area is exactly that. It's information, data, or functions that anyone can use as long as they have an object of this Cartesian coordinate 2D created. And private means exactly that. That it's kind of just like stuff I need to get my job done. Or in our case too, like the data that's being stored under the hood is going to be stored as private, because I'll give you a get method to get that information and a set method, but you cannot go and directly modify the data sitting under the hood inside this object. Okay, so numbers 1 and number 2 should be pretty easy here. Set up a member variable for x. And set up a member variable for y, because what is a Cartesian coordinate? It's a point on the xy plane that has a value of x for its x and a value of y for its y. I mean, it's just very simple stuff. So there is my private information. Let's see. Do we need any other? I don't think this problem is doing anything more with private stuff, so which is fine. But I think we're good there. And so now we have the ability here to start and continue on. So however you want to do this. Normally what I would do when I do this is I set up my private data. Then I figure, do I have get and set methods? And I look at that and I go, yep, 5, 6, 7, and 8 here listed. Those are my gets and my sets. Get x, get y, and then a void function to set x, and then with the new value. I'll use uppercase. You do what you want. Just make sure you keep it consistent. I'm going to use a lowercase here, and then I'm going to set y. And a lot of times what I like to do once I have this thing going or whatever, I put the sets and the gets. I put every variable separate so you can kind of get a feel for that. So get I can get and set X, I can get and set Y according to what I'm going to do. And so this is just the pure blueprint of everything. This is just setting up the architecture. Notice these little green squigglies. The function definition is not defined. And I'm not going to put it in here. I'm going to put it in another file, and I'll show you a cool way to do this without having to do a lot of typing in a couple minutes. And so, okay, and this is what's nice about with the data being private. I don't have to give access to the variable. I don't have to let you set, or I don't have to let you get. Just by eliminating this, I make it so you can't access X whatsoever. Like, you can't access X. It's a private variable. Sometimes you actually want that. Okay, so coming now to look at parts 3 and 4, how to set up the constructor here in the header. It gets the same name as the class type. It doesn't have a return type, which is weird. Constructors and destructors don't have a return type. And so now here is, part 3 here. I can have a default constructor which initializes everything to 0, and I can have a public constructor that takes inputs. So I'll do it the long way, and then I'll come back around later. So this is what this is trying to tell me to set up right now. I have a default constructor. A default means no parameters passed in. And that's what this is showing me. And with this, which initializes both X and Y to 0, we can do that inside of the when we define this this function. We can do that there. So this is not part of the header. And then the public constructor, which takes inputs for both X and Y. There's my lowercase x, there's my lowercase y, so I have all of this. And so before we get any further, I just want to maybe set this all up and set up these 6 functions. Because after that, it's a matter of now writing functions to use this thing in a manner and basically interface and interact this with other programmers and other objects that are in our code. Okay, so what I can do here is I can mouse over, hold down, click, and get all this stuff. I could right-click, quick actions and refactorings, and then go create declaration / definition. And then it doesn't do it. Son of a gun, why doesn't it do it? But what it should do is set up the functions inside of here. If for some reason it didn't work for me, which is fine, I'll show you how to do it by hand. But then what it does is it sets up all of these as skeleton functions, so I don't have to do all of the work I'm about to show you here. So what I will do now is just show you how to do it in case something like this comes up again. So the CPP file does need to include the .h file. Notice that those are quotes, not the angle brackets, the chevrons. And here are the six functions I've already set up. And so what you need to do is put Cartesian coordinate : in front of all of the function names. The data type for the return type always goes first. But remember, these 2 constructors don't have that. Constructors do not have return types, so it just goes like this. And then just replace those semicolons with curly braces, because we're actually writing the functions here. And all right, so there are all 6 of our functions. There you can see them, and that it's a skeleton, basically almost the same skeleton that we would see when if we were able to do that automatically. Okay, I don't know why this is void space. Oh yeah, because that's crazy that it did that. Okay, so let's see. The gets and the sets are easy. It's just you have to, if you're kind of new to this, you have to get used to the fact that I'm returning a variable called x that is not defined anywhere in this function. It seems weird, right? Because we're used to defining a variable and then using it. But we're not doing that in this case. We're returning x, and you're like, well, that's allowed, huh? I'm like, yep, I guess it is. And that's because whenever you are in something like this, this is scoped to the Cartesian coordinate 2D class. When you do something like that, that's saying that inside of this function, I get free access to everything that's in the header. Let me show you over here. So now you can see x is part of this guy. Even if it's private, I'm inside of a Cartesian coordinate 2D. I have access to everything public, private, and later on even protected for the next chapter's stuff. And so I can access x directly. And the same thing goes here. I can say uppercase x equals lowercase x. Get y, return y. And a lot of times this is as simple as these functions are going to be. There might be some checks in here, like maybe I don't want the x value to be less, like a negative value. I could put an if check in here. Say like if the x value is greater than or equal to 0, set it. Otherwise, I don't know, throw an exception or who knows what. Stuff that we'll cover in the next in a few weeks when we get to start talking about the standard library and exception handling and whatnot. So there you go when it comes to the gets and the sets. Generally very simple things. Remember, of course, the get functions always have to return something, and the set functions always have to have something as a parameter, because that information is being passed along to modify the data sitting under the hood here inside of this object. Okay, so the constructors kind of work the same way, but kind of don't, because you notice this, if you come from a Java background, this is going to be a little weird for you, but this is the way to do things. So for this, remember this said that the default constructor sets the x and the y values to 0. And you might be tempted to type stuff in here. And the only thing I'm going to type in here is the fact that I'm going to put nothing in here. It's that intentionally left blank thing that drives people crazy. But what we're going to do is use something called an initializer list. And that basically does all the same work as putting the data, putting everything inside the curly braces inside the body of the code of the function here, but it is a better and more efficient and more professional way to do things. So I'm going to say x is 0.0, and remember this is x and y are doubles. I think I did it right. Yep, they're doubles. So I want to make sure if I put this in as a default, I put it in a so I'm not converting an integer into a double and then putting the double into x and wasting extra time. That's actually a very expensive operation to convert double to int or int to double. Okay, and then the initializer list is as such. There's a colon, and then you start just listing the variables and then filling in details. And we will see as we get more advanced in this course that sometimes we do have to use the body here, but most times when we're initializing, especially simple things like this, like just a double value, that we're going to go ahead and do things this way instead of any other way. Okay, so this sets up x and y to 0, and now over here it's the same idea. That my capital X is going to be my lowercase x, and my capital Y is going to be my lowercase y, and nothing goes into the body here. And one thing of note that maybe, who knows, at an interview or something like that, they're going to ask you, and I've seen people lose a day at work because of something as stupid and simple as this, and what happens here is, what if I reverse x and y? You're like, oh my goodness, like that should be very simple. You set y to 0, then you set x to 0. And as you'll see as we get to more and more advanced things, sometimes we're dealing with pointers and memory addresses and newing up all sorts of memory, and the order of operations will absolutely matter. And like in this case, yeah, nothing is gonna, if I do x first then y first, or y first then x first, it's really not gonna matter. But the rule is, whatever goes, however things are listed in the header, that's the order in which everything is initialized. Even if you do it wrong over here, or if you switch it up over here, it initializes everything top to bottom from the header. So no matter what, no matter how I organize things over here in the header, in the implementation, the x is going to be initialized first and then the y. So you got to keep that in mind. Okay, so another thing to consider here also is that I have two constructors that double the work. So it gets a little confusing here. And so what we can do is we can also set things up so that we can reduce the amount of constructors that we have, or at least reduce the amount of work. Because we're doing double the work here. We have two separate functions that initialize all the data. So one of the newer things, newer meaning within the last 10 years of the C++ language, is that I can use one constructor to call another. So I can replace what you see here with, I just have to spell it right, Cartesian coordinate, and I can pass along something like this. So this default constructor gets called, And then it calls this other constructor and passes along a 0.0 for x and a 0.0 for y, and then it initializes everything the same way. So this is better because I'm not duplicating any of the code that goes into setting up all of these variables in the constructor. This constructor defers all the work to this constructor. And so one last thing I can do just to kind of take this even one step further, it feels like 2 or 3 steps further, is I can use this process of going through and setting up default parameters inside of my constructor. And you put this in the header, you never put this in the implementation. And so I can say, oh, okay, double x equals 0.0, double y equals 0.0. And what this says is that I now can get rid of this. Isn't this crazy? I can get rid of that, and I can get rid of that code here. And now I can use just this one constructor to do all of the work. And if I go ahead and I supply 0 parameters, it will supply a 0 for x and a 0 for y. If I go ahead and only supply 1 parameter, the x will be whatever my input will be, whatever value comes in as as that value, and the y will be set to 0. Or if I do use x and y as separate values, then I will set it to whatever. These are default values. Default meaning, basically default. What will happen if nothing is supplied? And so, maybe, I don't necessarily want to see that in your homework assignment as you submitted it, but this is definitely the better way to go about setting all of this up, is to have the least amount of constructors and everything doing the least amount of work. So what is it? What is Brad talking about here? Let me explain. Let me show you through this example. So let me include the Cartesian coordinate 2D class. So then what I can do here is I can set up an object A, and I can just set it up by default. Or I can set up a B where I only supply 1 parameter. Or I can supply a third one, C, where I can supply 2 parameters. And let me put a breakpoint in here so you can kind of, or put a breakpoint here so you can kind of see how this works out. We don't even need to see, there's nothing being printed or anything, so we don't have to look at the output window. But if I hit, this is where we are here. Let me move this over here just for the moment. And so if I hit F11 to go in, you can see I'm here, and I go up, and now x is coming in as 0, and y is coming in as 0. And that's because A does not supply any parameters, so it falls back on those defaults that I set here, right there. So then now, boom, boom, come through. A is all set up. Come on, A is all set up, and there is x is 0, y is 0. So B is not initialized just yet. That's why it's got all this garbage in here. And then I'm going to change that in a second here. So now you can see x is coming in as the 9 that I supplied, and then the y is coming in as the 0. And so you can better bet your dollar here that B is coming in at 9 and 0. And the same thing will go here. It's uninitialized in the moment, but once I get in here, my x is coming in as 3 and my y is coming in as 4. Everything gets set, everybody's happy, and there are my values for C and D. Or sorry, for C, the x and y values for C. Okay, so when it comes down to it, this is everything to do with, this is basically what I did here was everything, basically all chapter 13 stuff. The first 8 points here, half of this stuff is just getting the constructor and the gets and the sets and getting everybody happy, setting up the data, the private data, and so forth and so on. So now, adding on to this is now more chapter 14 stuff here. So now we're going to take a look at operator overloading and copy constructors and copy assignment operators and so forth and so on to finish up this assignment. Okay, so now we're going to look at number 9 here, start working our way through all of these different functions. So now this is asking me to set up a public function that returns the point's distance from the origin. So it returns a double, and it's basically just the square root of x squared plus y squared. So now, instead of just having gets and sets and the basic stuff, now we're adding, functionality on top of all of this. So the double is going to be the return type. Let's see it. I can say something like get distance. I do not say this is another little tricky thing if you're here watching this video, is that I do not have to supply any parameters. the x and the y variable for this object are known. They're being stored. So I do not need to supply that information from outside of calling it to get it to do its job. It knows what x is. It knows what y is. So I don't have to worry. And I don't need it for get functions as for the same reason. But I do need to pass something along for the sets, as I described earlier, because you're changing the data from whatever you already have under the hood to something new. You need to supply that data to the object so that it can go ahead and try to do so. Okay, so I have this get distance function, and I already showed you that this doesn't work, so I'm going to try it one more time. Let's see. Oh, it did this time for some reason. I don't know. And so now the function got put there. And now I need to just fill in the difference. Double is the return type, its get distance is the function name, and it's scoped to Cartesian coordinate 2D. And so as I was saying, it's just a matter of using the square root function, just making sure, nope, I don't have access to that. So I have to define that up here in this file. That's CMath. So there's my square root, and then I can just say x times x plus y times y. And many of you like to try to use the power function for this. But again, wouldn't you rather just have one multiplication? Then who knows how much work the power function, how much efficient and how inefficient it is for just trying to do one multiplication to square something. And so there is your get distance formula. And this is everything you need to do for this to get this thing to work. And I can try it out here. That if I do a cout, I just print out c dot get distance with an n line, it should print 5, right? This 3, 4, 5 triangle. And there's my 5. And if I tried to do it for b, I'll get 9, because 9 squared plus 0 squared, square root is 81. And if I do it for a, I'll get 0. So this is great. I have something that works. And so part 9 is done. And part 10 is just another variation of the same kind of thing. This time I'm going to return an integer value that tells me which quadrant. And so there's my quadrant part here. And so let me keep out of there. Okay, so for this, I presume everyone has enough of an algebra understanding to understand that positive x, positive y is quadrant 1. Negative x, positive y is quadrant 2. Negative, negative is quadrant 3. Positive x, negative y is quadrant 4. And anything on a line is, I just said, let's just consider that as quadrant 0. So if my x value is greater than 0, then I can go in here and say if my y value is greater than 0, I usually put all these curly braces, but let's forgo that. So if x is greater than 0 and y is greater than 0, then I'm in quadrant 1. Else, if y is less than 0, I am in which quadrant? I am in quadrant 4. But if none of that works, and if y is not greater than 0 and y is not less than 0, then y has to be equal to 0, I'll return 0. So no matter what, in all three of these cases, I return out. So I don't actually need an else down here, because once I get in here, I am out. There's a return under every code path. This code path returns 1. This code path returns 4, or this code path, the default returns 0. So now, when I come out, I know that my x value is basically less than or equal to 0, because if I don't go in here at all, this statement here was false. And so what makes that false is the fact that x has to be less than or equal to 0. So how about I just copy paste this and do almost the exact same thing, just swap things around a little bit. If my x value is less than 0 and my y is greater than 0, then it's quadrant 2. And if it's negative, negative, it's quadrant 3. But again, if the x value is on the line, then we're good to go. And so So now again, if x is not greater than 0 and x is not less than 0, the only thing that you can account for right here, x has to be 0. And so, so if all else fails and you fall through this if statement, you fall through this if statement, x is absolutely guaranteed to be 0. And if that's the case, I'm on the line, I want to return 0. So that covers it. I'm not saying this is the best or easiest way to do this, but this is definitely something that you can see logically to get the job done here, to figure out which of the 4 quadrants or 0 that these things are coming from. Okay, so now we're going to cover parts 11 and 12, and this, a lot of students seem to have trouble with this, the difference between copy constructor and copy assignment operator, since at the end of the day, I'm just taking the contents of one object and setting it equal to the contents of another object. So like, why do I need 2 functions? And it just comes down to a simple question, which I'll be talking about here in a minute. But let's just set up the syntax of it all first. So the copy constructor, usually you put that here in the, you have like a land of constructors here inside your header. And what you pass in, you pass a const object of the same type. Come on, Cartesian. Nope, it's not going to do it for me. That's okay. Coordinate 2D. Reference, and then I like to use the term RHS for right-hand side. That's just the way I do things. Okay, good. Only a green squiggle is good. Anything a red squiggle is bad. So there's my copy constructor, and so my copy assignment operator looks very similar, but it definitely is an operator. So I'm going to say, okay, it's going to return. It's going to have a return type, surprisingly, because you can chain these things together. A equals B equals C, something like that, right? And so C++ allows for that to happen, and so we should allow for that to happen too. So the return type for this thing is going to be a Cartesian coordinate 2D reference, because I'm actually going to return an address to one of the objects as I go along, not a copy of the data of one of the objects. And so that's the return type. I'm going to use the operator, which is operator equals. And on the right-hand side of this thing is going to be this const coordinate, or Cartesian coordinate. Now, it does not like me doing this here. Okay, whatever. But it is right. Cartesian coordinate 2D reference. And then I'm going to use the same RHS here. Let me move this over a little so you can better there. Okay, there you go. And so there are my 2 functions. And let's just get it working, and then I can show you on the other end what that they do work. So I can steal this guy and say, hey, refactor me, please. Okay, there it is. And then I can say the same for you. Say, hey, refactor for me too. Okay, where do these guys go? Up there's one, and where's the other? The other's up here. Okay, cool. And so the same thing applies here. This is the copy constructor right here. And again, it's a constructor. We already had 2 constructors, which we've reduced down to 1 constructor, and there really is no way to get around this. You can't reduce this one out, but I can do what I did before, and I can pass along. I don't have to do the initialization twice. I can just say, hey, why don't you pass along this data like this from this constructor to the other. This is, whatever the x value of this object is going to get passed along as the x, and whatever the y value of this object is, it's going to get passed along as the y. Okay, so then nothing goes into the body here as well. And so that covers the copy constructor, because when the closing curly braces hit by any one of these 2 constructors, 3 technically if you count the default behavior, that you're ensured that the x value and the y value are initialized when you close out of the constructor. Okay, so now coming down here, it's the same idea in a way here. So you're like, I'm setting my x to be equal to whatever the x value of the other object is. And since this is not a constructor, you can't use the initializer list. Okay, but now the thing is, this little tricky guy here again comes into play, because I should be allowed to say A equals B equals C equals D or something, and just keep chaining these things along. And because of this, I have to keep on returning one of the 2 objects, and it really doesn't matter which one you return, but it's just standard to return the me object. And the me object in this is the left-hand side of the equals operation. So like RHS is right-hand side of the equals. And then LHS, which is, or in this case, this object is what is on the left-hand side, which is me, if A equals B. So when there's a Cartesian coordinate on the left-hand side and a Cartesian coordinate on the right-hand side, this will get called, the right-hand side will be this guy, and this pointer will be the left-hand. I'm going to return myself so I can chain these things together. So let's take a look over here now. So I can say, okay, I'm going to set up D equal to B. And then right under it, I'm going to say D equals B again. And we've already worked through the first 3 lines here. So let's just take a look at this separately and see what's going on and see what the difference is here. Okay, so this is the copy constructor right here. And the reason I know this is because it's constructing an object in the same line of code as it's, basically setting something equal. This is exactly the same as putting D and then putting B in parentheses, because that is what the function, basically the copy constructor is looking at here. This B is it is a Cartesian coordinate 2D, and that's the right-hand side. But you're allowed to do things with both syntaxes if you want. It really doesn't matter. There might be a slight performance hit, but I can't remember if that's true or not. So sorry about that for those of you wondering. But now, just even so, because D is being constructed in this line of code, it's going to go into the copy constructor code, and there it is, and set everything up like I expect it to. Boom, boom, boom. Oops, let me do this again, just to show you how things go. F11, F10, F11. See how the function call went into this guy, and now it's moved up to this guy to set everything up, set up my X, set up my Y, and come back. And now you can see my D is set 9-0, like it's supposed. Both of these are set to the same values. They're both different copies of the same value. So now this line of code uses the copy assignment operator, and that's because when I get to this line of code, D is constructed and B is constructed. There's no constructing going on. All of that information is being stored somewhere in data, somewhere in my programs, somewhere in RAM. And I don't have to worry about constructing anything new. So now, because of that, it's the same behavior at the end of the day, but we have to have a separate function call to do this, right? X is equal to RHS.x, Y is equal to RHS.y. And so now I could actually chain this together if I want, and everything will work right to left. Let me just put a breakpoint here now and just say, okay, now I can do things like this. D equals B equals A. I can't necessarily do that with the copy constructor. But now you can see that A is 0, 0, B is 0, 0, and D is 0, 0. So everything got chained along, and basically everything goes right to left. We're used to reading left to right, but everything in this case went right to left. Everything in A went to B, and then everything in B went to D. And that's why everything is now set to 0. Okay, so that covers the first 12 parts of this. So now we've just got a few little odds and ends here. The minus operator, the minus equals operator, the cout operator, and then the greater than operator. And I'll be doing that right now. Okay, so the final steps here are to handle the 4 operators: minus equals, output to the screen, output to the stream, and then greater than operator. So .h file is over here. So let's take a look at, we've already got all these other things. So let's see, we're kind of used to what these operators look like. We've already seen this one. Let me see if I can get a little bit more. Okay, so the minus operator. C equals A minus B. So what am I returning? I'm returning because that operation doesn't modify A, it doesn't modify B, but it creates a whole new object from it, and it just goes with it. So it actually is a Cartesian coordinate 2D object, but just a value type. This is not a reference, because I'm going to return from my function a local variable, and it's going to be copied over as a value type. Because if I return this as a reference, you'll see this later, and I try to return a local object, then things will go terribly, terribly wrong. So there. And this should be probably a Oh, I think we could leave it as such, a minus operator, but we want this as well because we're not modifying I'm not modifying myself. I'm not modifying whatever's on the right-hand side. I am just modifying. I'm just modifying and creating a new object. So let me do this quick actions in factory. There we go. Where is my CP? Where did my CPP file go? Let me. What do I get for trying to do things on one screen? Okay, let me pull this over and get to there. There it is. Okay. So what are we doing? It even filled it in for me. I'm going to try to return a new object. I'm not newing it up. It's just a temporary. But again, I can use the constructor, and I can say it's whatever my x is minus whatever the right-hand side's x is. And whatever my y is minus whatever the right-hand side's y is. So that actually should do it. Let's try it out. Let's make sure. Let's see. I have B. Let me just set this up. 9, 6, C. And so let's just say D equals B minus C. All right. So, and let's see how that goes. So when I get here with my code, B is 9, 6, C is 3, 4, 9 minus 3 is 6, 6 minus 4 is 2. So D should have a 6, 2 as its coordinates. Oh, let's put the breakpoint in there. There we go. We go in here. B is 9, 6. C is 3, 4. I go in, and you can see here's the minus operator. It's not easy to determine. It doesn't show us really too much here. So we'll have to come back, and we'll say now this should take us to the equals. Isn't that interesting? Because all of these are operators that we've overloaded. We overloaded the minus operator, and then we also modified and overrode the equals operator. So that goes in there. And now the right-hand side, I got to hit 10 one more time. There's my 6, 2 I was talking about. And so now everything's going to get set accordingly because it's just going to take that and you're going to set to 6, 2 and return this, which we don't need anything. So there it is. My D is 6, or my D has an X value of 6 and a Y value of 2. So there is my minus. Cool. Okay, so next thing to do is minus equals. So now this is modifying the value of myself. The left-hand side is being modified here. And so this is slightly different than the one we just did. So let me bring this up over here and let me make this more visible again. So now the minus equals is very similar to the equals. It's going to return a reference because I can chain these things together and I'm modifying my object, the me object, whatever you want to call that. And so now I can try that out. And it looks very similar to what we've already done. There's that. It looks very similar. I could basically just copy paste this. Just got to be always got to be careful when you copy paste because it's very easy to make a mistake there. But all I'm doing with the minus equals operator is saying whatever my x is, subtract off the right-hand side's x. Whatever my y is, subtract that off, and then return that just in case. Okay, so I can do this. D equals B, and then I can do D minus equals C. So this should get us, well, almost to the same place, right? Well, D will, we'll see. So let's see. C is 3, 4. D is 9, 6. So at the end of the day, this should get us right back where we started from. So here's the minus equals operator. Boom, boom, boom. My x is now 6 and 2 like it was before. So yep, it's working. And the minus equals is good. Okay, so that covers that. And then the final two here, so we can start printing things out, is the print operator, just to keep things simple. And this one this one's the trickiest, the hardest of all of them, right? Like this requires a friend function, this requires a whole sorts of, this operator requires a lot. Because this operator here, it actually is not a member variable, or it's not a member function, it's not a member operator, I guess, and it's not a global operator. It's like this thing in between. It's a friend. So what I'm going to return this time along, so I can string these things together, is a stream, and std : o stream reference operator. Let's see if I need You're going to scream at me? I'll probably need to include something in a minute, but let's just try this out. The left-hand side is a stream, right? Because I want to print. I want to do C out, like this. Instead of C.distance, I want to print C, like that. But it won't let me because it doesn't know anything about the right-hand side being an object and the left-hand side being a C out string. So the left-hand side of this, so this is one of those times where it's a different operator. Like this is the third kind of operator we're dealing with, right? We dealt with this kind that returned references. We had this that just returns value types. And now this as a friend function is completely different. Because it's not a member variable, it needs two parameters. The first one tells the compiler what's the left-hand side of this operator, and then the other one says what's the right-hand side. So I want this stream again. You don't want it to be constant because once you throw information into it, right? Once you've thrown a stick or a rock into a stream, you've changed the stream. Just when we put information into it, like data to print to the screen, then it's the same thing. And I use Oster for this instead of LHS. This is like the only time I break my conventions. And then the right-hand side should be a const Cartesian. We might have to fix up a little bit here to make this thing work, but we should always use const correctness as it should be. Did I spell Cartesian right? Definitely didn't spell coordinate right. So let's see. Does that turn green on us? Yes. Okay. So there is a lot going on there, right? Here's my operator. This is the left-hand side, which is a stream. The right-hand side is an object, and then that's the operator. It's a friend because it's not a global, it's not a member, and then it's returning a stream. So that if I want to, I can combine and just start combining things together like this, and just start going crazy. So it keeps returning the stream as I go right to left, or I guess left to right. I guess how you want to think about it. Okay, so and now say if you haven't seen linker errors before, this is where things start to pop up. Anytime we use object-oriented programming, let's see, OStream. Okay, yeah, that one's screaming out because OStream we need to include IOStream here. Whatever that is. Okay. See how this fixes things. Yep, that fixed the compiler error, and now we have a linker error. It's like, well, what is going on? Like this file says everything is okay. This file kind of doesn't, but this file, you know. And so what's going on is on a file-by-file basis, everything compiles correctly, because this is just a blueprint. This is not the function definition for this, right? And so when I do this here, this file says, oh, hey, cool. The Cartesian coordinate class has this function set up, and it promises me this, and it goes, okay, cool, and it just continues on. So this file compiles just fine. And this file compiles just fine too, because this is saying, oh, hey, in some other file in my project, I'll find this function. But when it all comes down to it, that function is never defined. And so every file compiles correctly, but when it comes time to tally everything up in the end, and the linker brings everything around and goes, hey, let's make one program out of all these individual object files that we've created, this is where it goes, hey, I can't find that. And you get a linker error. And as you can see, this is tame for a linker error. And I mean that. This is tame for a linker error. You can end up in linker hell if you're not paying attention, or if there's little tiny details that you don't realize. Okay, so to get out of linker hell, you have to define this function. Let me steal this guy so I don't have to. And it's not a global, it's not a member, so I don't have to go ahead and I can't go ahead and put Cartesian coordinate : : in front of it because it's not a member function. Okay, so now what do I want to do? I want to print this out. I'm not going to go to C out. It's very common for you to go, oh, I'll just put C out here. Like, no, that's what Oster is for, the OStream. And so, because maybe I want to use this to print to a file, or maybe I want to use this to print to the screen, or whatever other kind of streams there may be. Like, I don't want to hard code this accidentally to C out. And we all do it. We just have to be careful. So what do I want to print? I want to print a little parenthesis. I want to print the x value, or can I use x? Oh, I guess I can. Cool. And then I can put a comma, and then I could put the y value. Then I could put the closing parentheses and call it a day. And then I can return Oster to keep the chain going. So let's see if everything now is happy. Got a oh yeah, that warning always pops up. That's why things break for me at some points. But I have no errors. And now you can see when I go to print things, oops, there we go. So there is my A value, which is 0, 0. There's my D value, which is 6, 2, like we discussed. And there's my C value, which is 3, 4. There they all are printed out on the screen. So my operator is working. It's up, like usually you want to keep to the smallest representation of this. Like, so to me, this is perfect because it's small. You're not forcing the user to use a giant print statement or something, and it gets its point across. So for me, I'm happy with that. Okay, so the final operator here is the greater than. And so this is kind of the same thing. You go, the same thing but different. And I go, is my point closer to the origin than some other point? Yes or no? And so I can use that get length function that we defined here in the .h to make this work, right? Get distance. I'm sorry, get length, distance, same deal. And so what I want to do, this case, any one of the 6 operators, right? Greater than or equal, less than or equal to, equal or not equal, these turn out and give us Boolean responses, true, false Boolean responses. So this is actually going to be a bool operator. And I think it was less, let me just make sure. Was it less than again? It was greater than, sorry. Okay, and then the right-hand side, I'm not modifying anything, I'm just testing whatever values are there. And so it's just going to be a const Cartesian, oh, it never fills in for me. Cartesian coordinate 2D reference RHS. So we did the hard one. This guy is done. The stream operator, that guy is done. So here is that, return false. And this might be as easy as you think. I'm the left-hand side, so I want to say, hey, if I say get distance, is my distance greater than the distance of the other guy? And this is where things are going to break down slightly for us, and we're going to have an issue here because of one thing I neglected way back in the day here. And the error message isn't very clear. The object has type qualifiers that are not compatible with the member function, blah, 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 blah. And what it comes down to is that I made this thing a const object, but this function is not const. And so even though we know that we don't modify inside of this operation here, where is it here? Get distance, we know we're not modifying x and we're not modifying y. The compiler doesn't know and doesn't care. It just knows that we didn't throw the word const in front of everything like that. So any get function should be const. And so that goes for these guys too. And equals is setting, minus actually is a const. I don't want to get too much into it, like, all that kind of stuff. But this operator greater than is also const. Let's see if I don't know, sometimes it won't let you do these kind of things. I guess, yep, it will. So then I have to throw the const in front of this here, or at the end of this thing, right? Make this thing work. Okay, and then the others need that. Pretty much everywhere you see red squiggle, I got to slap the word const on here at the end to indicate that this function does not modify any of the member variables. And now I can rebuild. Let's see what comes up. Oops. I get yeah, now the error went away and I'm back to that original one warning that isn't really a warning. So everybody seems happy here now with that. And so I can test that. I can say like cout, or I'd say if D is greater than C, cout D. else C out C. And so just to remember, D is 6,2 and C is 3,4. So this is going to be greater because the distance from 6,2 to the origin is greater than 3,4. So there's my D right there. And so everything is working. Every one of my 16 things is done. Let me see if I can I pull this up? Too much code, but you kind of get the point here. What have we done in the last couple 15, 20 minutes here is these new guys, these operators, equals, minus, minus equals, greater than, yeah, arrow, arrow, and then even the get quadrant equals. All these functions are done. And again, notice how all of the code is in here in the CPP file. All of the header information is here on the .h side. And then we never use this directly inside of here. We only use it from other files. So those are the blueprints that we go to figure out what we're going to do. Okay, so that covers this problem. Pretty long problem, pretty long example to describe anyway. Maybe it even took you quicker to do, which probably is true. But if you have any questions or concerns, if I misspoke or nothing or something doesn't make sense to you, please absolutely get back to me at swardb@cod.edu, or you can get a hold of me here on YouTube. I'll get back to you as soon as I can. Okay, so next, inheritance, polymorphism, virtual functions, those kind of deals. That's what we're looking at next. That's where all the powerful functionality of object-oriented programming is used, and also we're going to have to deal with pointers to make this thing work the way we want to. And that's like, why do we teach pointers? And why are the pointers are even here? When we're describing this stuff, you're going to get to see why. And we absolutely have to use pointers to make polymorphism and inheritance work. Anyway, so thanks for sticking it out with me as always. Have a great day, everybody. Take care, and I'll see you next time.